Having completed the design of the robot, I've noticed I've added a fair amount of weight towards the front of the robot, and I'm concerned that that may be causing a problem. So I'm going to check this by first of all going to a constraint that I placed on the arm called Drive Me Claw Arm. You'll notice that as I move that up and down, the weight actually goes further away from the axle, the front axle, and higher in the air. And that may cause the robot to topple over, which wouldn't be a good thing. So let's see how we can check that. I'm going to view the center of gravity. Ideally, we want the center of gravity to be as low as possible and between the axes of the wheels. Well, it's reasonably low, but it's awfully close to that front axle. So let's suppress that constraint. And I'm going to move that up so that I'm actually moving the mass higher in the air and further away from the axle, which will have an impact on the center of gravity. So let's just refresh that. And indeed, you can see the center of gravity has moved up, but it's moved much closer to that axis. In fact, it's right over the top. So I would suggest that we do have a problem, and by using the software, we identify what that problem is. What I need to do then is add a counterweight to the back of the robot. So I've put together a counterweight using the parts from the kit, which is allowed in the competition. This consists of a couple of wheels and a C-channel. So I want that to be as far out of the back of the robot as possible to counteract the weight of the scoop design that I have at the front. So again, I'm going to use iMates to attach this. Grab onto the first iMate, Alt key, release, snap that into place, swivel that around, and do the same thing. So we'll snap those two iMates together, and then we'll look at the assembly again. And you can see that counterweight's really hanging out the back of the robot. So let's look at that front view. And in the 0 degree position, let's check the center of gravity. So the good news is that the center of gravity is fairly low down, but even better, it's moved away from that front axle quite significantly. So let's change that angle again. So again, what we want to do is find out the worst condition in terms of the center of gravity. To do that, I'll rotate the arm again so that the weight is high and further out. We'll refresh the center of gravity. And on review, it certainly has moved up, which is what you would expect. But the good news is it's still nicely set back from that front axle. So that counterweight has solved the problem.